What's up guys, this is What's Up Chan. Today in this video I would like to present my research that I did last Thursday, and I also would like to talk my feeling and the things that I learned through this research presentation. Please enjoy.
The topic of my research is radioactive waste, how to handle it efficiently. This is my index. Purpose of this research, potential of nuclear energy, and I would like to explain how nuclear energy and its waste are provided and its solution. Have you guys seen this poster? This is the picture to remark the danger of global warming. And the research has told that the primary source or the main cause of global warming is fossil fuel. Even though fossil fuel is so dangerous, the primary energy fuel chart shows that the world requires the great heat power of fossil fuel. It fossil fuel takes charge of 85% of energy of primary energy source supply of 1 year. However, to reduce the amount of fossil fuel, there should be another source of energy that is to reduce global warming. There should be another energy that can replace fossil fuel, and that energy should be eco-friendly and efficient, and that is nuclear energy. The potential of nuclear energy is that it has positive effect, that it is highly efficient as shown in this equation, and it is also eco-friendly since it does not emit any toxic gas. However, it has negative effect. Since the first events that nuclear energy was shown is nuclear bomb happened in World War II, people are afraid of nuclear energy, that it can be used as nuclear bomb. And in 1986, the Chernobyl nuclear power plant was exploded, and it caused really harmful effect around the city. And the most detrimental factor is the nuclear waste. Nuclear waste is produced after nuclear power plant produce energy, and it is really radioactive and hot, that it is hard to dispose, and it continues for a long period. But back to the point, even the possibility of nuclear bomb and nuclear power plant collapse, it is just a mere account compared to the continual damage by fossil fuel. So I found that if you're able to reduce the fossil fuel, if you're able to reduce or handle nuclear waste, radioactive waste well, the nuclear energy will be a good source to replace fossil fuel. So I'll briefly explain how nuclear energy and its waste are provided. Nuclear power plant needs the great amount of heat, and this great amount of heat is produced by nuclear fission. Radioactive element, especially uranium, has characteristic to split into other atoms when it encounters a neutron that moves in great speed. So uranium element crash with uranium element bump with neutron and split into two atoms, and this process is called nuclear fission. And during nuclear fission, the great amount of heat, which is the thing that nuclear power plant need. So in this furnace, the great amount of heat is produced, and to control this heat, a cooling agent or water is put inside to the furnace, and as the water absorbs all the heat, the water becomes steam. And the steam passes through a tunnel, and in this tunnel it is connected to a turbine that will spin electricity generator, so that it converts kinetic energy of turbines to electrical energy, and this electrical energy is the source that nuclear power plant requires or will supply. And there is a uranium plant, and that uranium plant is used for 4 years in the nuclear power plant. And after 4 years, about uranium-238, the 94.6% of the plant is uranium-238, 1% is uranium-235, 1% is plutonium, and 3.4% is other radioactive elements. In nuclear fission, the most important element is uranium-235 because only the uranium plate is composed of uranium-235 and 238, and only 235 is able to react in nuclear fission, and 238 is used to control the chain reaction so that nuclear fission will not be so great or excessively great. And after the nuclear fission, uranium-238 reduced loss 32 kilograms, and uranium-38 lose about 30 kilograms. And some of uranium-238 is converted to plutonium, and it is interesting that plutonium is also possible to react in nuclear fission. And I and all these left elements are nuclear erased radioactive waste, and I was looking for a solution. There are lots of solutions, but the most efficient way of handling is recycling, which is called pyroprocessing. This is the step for pyroprocessing. It is composed of electrorefining, electroreduction, electrorefining, and electrosmelting. This is the radioactive waste. Radioactive waste is connected to this battery, and through this electroreduction, oxygen contained in this radioactive waste is disposed, so it is separated. So after this reduction, current of electricity helps it to remove all the oxygen inside this waste, and thanks to this process, waste is able to be react in electric conduction, and it is moved to electrorefining. Electrorefining is the process of separating one element and sending to another charged pore or anode. This is cathode, and through this refining, only uranium-238 is separated and moves to anode as the state of pure crystal. So through this refining, uranium-238 is separated as the pure state, and rest of the radioactive waste are left. And in electrosmelting, rest of radioactive waste is melted together to become a radioactive compound. And this is the end of pyroprocessing. There is a pure uranium-238 and compound of radioactive waste. And these two sources are used as another nuclear source. This will be used by another nuclear power plant called fast breed reactor. Fast breed reactor uses uranium-238 and other radioactive waste. It caused uranium-238 to become plutonium, and it used plutonium as nuclear fission source. And after this process, there will be also another kind of nuclear radioactive waste, which is strontium and cesium. But strontium and cesium has half-life of 30 years, and Nuclear Research Institution has reported that about 300 years will take to finish all the half-lives, or the period of danger will go of strontium and cesium. And in addition, I did not research a lot, but there's an institution find some special bacteria that will dispose cesium. So if it is commercialized, the bacteria will dispose the amount of cesium, and it will reduce the burden of keeping the amount of radioactive waste. So thank you for watching.
So I presented my research paper, and now I would like to tell some things that I learned through presentation and also feedback got from the referees or teachers. First of all, teachers had told me And that since this topic was really scientific, teachers asked me to talk about who the audience of my research is. Well, I was thinking the audience was the teachers who had enough knowledge of all nuclear things, but I was supposed to think of other young students, so they asked me to present some present that everyone can understand. Like I just approached the knowledge by one first dimensionally, like so easily, and I just said this is this, but it would be effect. I learned that it would be effective if I describe this knowledge by using some fun or easy to understand analogy, and this will be applied not only for this presentation, for all communication, so that every listeners will be interesting to my presentation. Yeah, I think I did not think about the audience interest. And another thing, which was the during my research when I described about pyroprocessing, I used a picture which is from the CORAD, which is Korean Nuclear Reactor Research Institution. And I used this because pyroprocessing is most developed in Korea, and I needed such specific picture. But since not all the teachers are not Koreans, some teachers felt something it was not felt it was not effective to understand for who are not Koreans. So one of my teachers suggested me that if it was necessary to use the Korean picture, I should have explained why I use this Korean chart and do they kind of apologize for using this chart. Yeah, so I also learned that if I use my native resource, I would have to explain because difference in because it's not written in English. And now I also like to tell the things that I feel being have unsatisfied feeling that there were several questions or several advices as the weakness, but there was I could have refuted, but I didn't because I thought it was a kind of struggle. But now I think it is the necessary part of research paper. First, uh, first, the first retort was that after pyroprocessing, there are all 300 years will be taken for strontium disposal. And the teacher mentioned that 300 years is so long. But I just said, okay, but in my point of view as a person who had research, 300 years is still a great process or great achievement, but achievements of science, because think about the half-life of uranium. The uranium half-life is 700 million years. It means it will take more than 700 million years to dispose. And through this pyroprocessing, it reduced this much years to only 300 years. And this is why 300 years is still a great achievement. It may be long for someone, but if you're able to see how the if you're able to see the half-life of uranium and the potential that it can be handled, it has the possibility that it can be handled in our time, is showing the great achievement of uranium disposal. Third thing, they also mentioned that even though I talked about bacteria, the teacher asked me it would be good to talk more about bacteria, but I should have said that like that way, teacher, my main today's my main point of research is pyroprocessing, and bacteria is just one thing that could be held as future reference. So the reason that I did not talk much about bacteria is that I did not research about this, and this is not the related to my main topic of research. I just found out that another second possibility or that will be used as future reference. Yeah. So I should have told that bacteria is not the main part of my research. And last thing, as I talked before, the teacher talked about using Korean chart, but I do not agree that using Korean chart means only Koreans can understand my presentation more, because in original picture that I got, there was a specific explanation of Koreans, but I deleted so that teachers will not be confused because of on the words, because of the language that they cannot understand. I even erased the meaning so that they will not be confused because of this Korean chart. And I've never used the term or words included in this picture to explain my representation. The only thing that I needed was the picture that helps to understand my explanation. So even though there were some words like uranium is written in uranium, and electro-refining, reduction, and smelting is translated in Korean in upper parts, I do not think it will help them understand because all the words are explained in English. So I should have told that even though there are some Korean words listed in this picture, it is never related to my presentation. I did not use the power of text here to support my presentation, so I do not. There must not be any difference, even of understanding my presentation, even if the same picture really brought from American source, from English language source. So I presented my research and also shared some feedbacks, and I also talked the things that I wanted to refutate the sayings, the questions from my teachers that I did not really say. And the last thing that I learned, I should be courageous or confident to refutate any sayings of listeners, because it means it is a good communication. So thank you for watching this video. It is quite long. Thank you for watching this. Bye.